All right, for this last problem, what we're going to be doing is finding the intersection of the line formed by the intersection of these two planes, 2x plus y plus 3z equals 8, and 5x plus y minus 2z equals 10. Now this is akin to finding the intersection point when we're given two lines. So the process is going to be quite similar. We would use the process of elimination if we had two lines and wanted to find a point. So here we're also going to use elimination to find the equation of a line. So I'm going to start by just stacking these up, and I'm really excited because if I just subtract these, the y's will disappear. So I'm going to go ahead and do that, and I can see that when I subtract, my y's are gone, and I get negative 3x. Let's see, 3 minus negative 2, so plus 5z equals negative 2. And I'm going to go ahead and solve this equation for z. Now I'm in two variables, and I'm going to say, let's see, 5z equals negative 2 plus 3x, and z equals negative 2 plus 3x all over 5. Now, for my equation of my line, I'm looking to write a parametric equation. And I already have an equation for my z part, but it's in terms of x. Well, if I just let x be t, then I can write my z equation in terms of t. And so I have my first equation all done. And all that's left now is to write an equation for y in terms of t, and t is the same as x. So in order to do that, I'm actually going to want to cancel out z the next time I do this. So I'm going to take the equation of my lines, and I'm going to rewrite them so that the z's are going to cancel. So I'm going to multiply my top one by 2, 4x plus 2y plus 6z equals 16. And I'm going to multiply the bottom one by 3. 15x plus 3y minus 6z equals 30. Once I've done that, I can add them this time. Adding will make these cancel. And so as I add, I get 19x plus 5y equals 46. And now I'm going to solve this equation for y. So 5y equals 46 minus 19, and therefore y, I'm simply going to divide by 5 to get y. There we go. Oops, I missed something. 19x. There it is. All right, so then I come up here and I have an equation for y. Y equals 46 minus 19. It says x, but I said x equals t, so I'm going to put t here all over 5. And now I have a parametric equation for the line of intersection between these two planes. Now, does it matter which variable got t? It doesn't. I could have had y equal to t, I could have had z equal to t, but then my other equations would change, and I would write all my equations in terms of whichever variable was set to t. Good luck on your homework problems like this.